Hello, I am Dr. K, and in this video we will examine the arthrokinematics of the wrist joint. Wrist joint is created by two articulations, radiocarpal and midcarpal joints. The radiocarpal joint is created proximally by the radius and distally by the first row of the carpal bones. The midcarpal joint is created between the proximal and the distal carpal rows. The proximal row of the carpal bones includes the scaphoid, lunate, triquetrum, and pisiform. The distal row of the carpal bones is created by the trapezium, trapezoid, capitate, and hamate. The wrist joint possesses 2 degrees of freedom, flexion and extension in the sagittal plane and radial and ulnar deviations in the frontal plane. The movement at this joint can be viewed from 2 separate perspectives, open and closed kinematic chain. An example of open kinematic chain is bending a wrist to bring a spoon to the mouth. Here, the proximal segment is fixed and the distal segment is moving. This movement involves movement of the carpals on top of the radius. An example of closed kinematic chain is a push-up. Here, the distal segment is fixed and the proximal segment is moving. This movement involves the movement of the radius on top of the carpals. Distal radius is concave. The 2 carpal rows are convex. Now, let's review the convex-concave row. When a convex object moves on a concave, the roll and the glide occur in the opposite directions. But when a concave object moves on top of the convex, the roll and the glide will occur in the same direction. Let's examine the open kinematic chain flexion. Here we observe the convex proximal row of carpals and distal row of carpals roll anterior and glide posterior. With extension, we observe the convex proximal and distal rows of carpals roll posterior and glide anterior. Now, let's take a look at the radial deviation. Just as with flexion and extension, we observe the roll and the glide in the opposite directions. So, with radial deviation, the convex proximal and distal rows of carpals will roll radially and glide ulnarly. With ulnar deviation, we observe the proximal and distal carpal rows roll ulnarly and glide radially. Now, let's examine the closed kinematic chain movement. Here, we observe the concave distal radius glide anterior and roll anterior. With extension, we observe the concave distal radius roll posterior and glide posterior. Now, let's take a look at radial deviation. Just as with flexion and extension, we observe the roll and the glide in the same direction. So, with radial deviation, the concave distal radius rolls radially and glides radially. With ulnar deviation, we observe the concave distal radius roll ulnarly and glide ulnarly. I hope you enjoyed this video. If you did, give it a like and subscribe.